Hi, today we're going to be talking about section 1.6 in the pre-calculus book, combining functions and their inverses. And in exercises that we're given, we're going to have to use the given functions to find the indicated value or functions. So when we look down at the problems, right away we see that we're going to be dealing with the inverse of this f function and this g function. So we might as well go ahead and do that first. So as we look at the f function, we know that we have f of x is equal to 1/8 x minus 3. So we know we better call this y, because we're going to have to find the inverse, which means we switch the x and the y, and then we solve for y. So we add 3 to both sides, and we can multiply both sides by 8. And here we have our inverse function. So we know that the inverse function of f is this. Now, whether or not you want to distribute that 8 or not is up to you. We'll just go ahead and distribute it. And now we want to find the inverse function of our g function. So we're going to call this y. And then we switch the x and the y. And we're going to solve for y. So we're going to have to take the cube root of both sides. And we see that the inverse of our g function is equal to the third root of x. Now, as we work through any of these problems, if you think you can work it, you can stop this video and see if you can work it out on your own, and then start the video and see if you got the right answer. I always suggest doing that. You could have done that for finding the inverses. So now we're going to go ahead and solve. We're dealing with our f, our inverse of f function, and our inverse of g function. And remember, when we have this type of notation, we start on the right side, and we're going to find the inverse of our g function of 1. So look at our g function. The third root of x. So we're just going to go ahead and put our 1 in, and we're going to find that we should have put a 1 there, is equal to 1. So now we want to put that, so we've done part of the problem, but not the entire thing, because we actually want to find the inverse of what we've just found. So now we're going to come to the inverse of our f function, and we'll be putting in 1. And we find that our answer is 32. Now as we come over to the next problem, see if you can do that on your own. We'll be, again, starting over on this side. And we'll first need to find the inverse of the f function at -3. isn't this convenient? Negative 24 plus 24 is equal to 0. Nice. So this value is 0. So now we're going to find the inverse of our g function of 0. Should make that easier. So we come back up to our g function, which is the third root of x, but we're going to be putting in 0. So we're going to find that our answer is 0. Now as we go up on to our next problems, we're going to again be working with the g functions. And as you might think, we will be finding this part first. So we're going to take the inverse of our f function of 6 and we find the answer is 72. But wait, there's more. So that is only this part here. We are going back to our inverse f function, and we're going to find 72. So we're back at the same function. And when we compute, we're going to get 600. Now, actually, I think that this next problem, 76, is the hardest one of this grouping, just because of the square root things that we're going to have to deal with. But see if you can try it and get a start, and if not, come back, see if you get it right. We'll start with this part. We're going to be using the inverse of our g function at -4. And keeping in mind that the inverse of our g function is the third root of x, but we will be putting -4 in. So we've got that, and now we need to find g, since we haven't finished the entire thing, of this. So when we do that, we basically remember our g, the inverse of our g function is the third root of x. So when we go to put the third root of x instead of x, we're putting this. So this lovely problem looks like this. And I think what makes it hard is you don't work with these types of radicals all the time. So what do we get? Well, we know that we could switch over to make our, instead of using radicals, we could have fractions for our exponents. But I think it's actually going to be a little bit simpler to deal with it this way. And we end up getting the 9th root of -4. And now we'll go ahead and switch it over to a fractional exponent, and we get, it's going to be a little bit easier just to put it like this. Yes, my technology is messing with me. All right. Thank you, technology. So what we have is -4 to the 1/9, because the index becomes our denominator, and then we had to basically have a 1 for the exponent here. Now, let's recognize that we can simplify this a little bit further. So let's just take our negative out, and we know that 4 is the same thing as 2 to the 2nd power, and that is to the 1/9. And keeping our exponent rules in mind, we know that we basically have to multiply the 2 times the 1/9. Here's our base, this 2 here. And then as we multiply, we get, we'll just close that. to the 2/9. And that is our answer. All right. Let's move on. Again, I encourage you to try to work the problem first and then take a look at this. So here we have f of g is what we want to find first, and then take the inverse of it. So keeping in mind that our f function, no longer dealing with the inverses, we're back at the regular, just the f of x equals 1/8 x minus 3, and our g function is equal to x to the third. So when we see that we have f of g, this part is going to be put in the place of x in the other function. So what do we get? We get 1/8 x to the third minus 3. Now let's just go ahead and put a y here, because the thing that we now need to deal with, we found f of g, it's this, but we want to find the inverse of the function. So what do we do to find the inverse? We have to switch the x and the y. And then we are going to solve for y. So let's add 3 to both sides. And we can just go ahead and multiply both sides by 8. And then that gives us y to the third on this side. And obviously we have to take the third root and so we'll switch the sides. Y is equal to this lovely thing. And in this case, it actually works better to leave this as it is instead of distributing the 8, because we know that 8 is the same thing as 2 to the third. So we know 2 to the third is 2 times 2 times 2, which is 8. So therefore, when we can take out our 2 on the outside, we still have the third root, and we have x plus 3 either in parentheses or not, and that is equal to y, and that is our answer. And then lastly, number 78, we're going to be dealing with the inverse of g of f. So let's think, what is the inverse of our g function? You remember it is the third root of x. And the inverse of our f function is 1/8 x minus 3. So when we see this notation here, we are going to take this and put it inside here. So how does that look? The third root of 1/8. Oh, darn. Wow. Okay, so I wrote the wrong function down here. This should actually be, the inverse is 8x. I went back to the original function, plus 24. I knew that wasn't right. So what we have here is 8x plus 24, which you may say to yourself, wow, that's what we had over here. So what we need to do is remember that we could take our 8 out, factor out an 8, knowing that 8 is made up of 3 2's, 2 times 2 times 2, and then take out that 2, right. And that is the final answer. Thanks for watching.